Hey gang, today we're going to be working on spheres, focusing on their volumes, surface areas, and cores. Um, Mostly you won't need to know about surface areas too much, but there can be some trick questions that seem like surface area questions, but that end up not being surface area questions, and we'll do one of those. Um, but it is important to know the volume of a sphere, which you might have done in, ninth grade geometry or 10th grade or eighth grade and when you were younger, but doesn't really come up in high school, but is very common on the SAT. So we'll work on that. And there's a reference sheet with the formulas, but it's not very useful to know to use the reference sheet. It's better to know the formulas in your head to work faster and to be familiar with them. So the formula is volume equals 4/3 pi r cubed. The way I remember that is that r cubed makes sense because it's volume, right? So cubic inches, cubic meters, cubic feet, however. And then because there's a 3, I have to remind myself I'm dividing by 3 somehow. And then I just have to remember that there's a 4. Okay, so that's kind of a trick, but you just have to memorize it. And then it's nice because there's really only one variable, right? Just radius, unlike prisms that have length, width, and height. So we'll go from here. The ratio of sphere A's volume to sphere B's is 27/8. What is the ratio of their radii? Okay, great. So you could do this on a more theoretical level where you set up a ratio like 27/8 equals, let's say A equals A's radius and B equals B's radius. So you could set up something like this and then do 4/3 pi a cubed over, that's a terrible 4. Sorry about that. 4/3 pi b cubed. Okay. And then the 4/3 cancel, the pi's cancel, and you're left with 27/8 equals a cubed over b cubed. And since a over b are both cubed, you can cube root everything to just get a over b. So a over b equals, the cube root of 27 is 3, and the cube root of 8 is 2. So your answer would be 3/2. Now, this one's pretty straightforward, but there are ways that might get confusing, right? Some people will try to find an actual volume for A or an actual volume for B, and you can't know that. You just know their ratios, but all the question is asking for is the ratio of their radii, right? So I found A over B is 3/2, but that's not saying that A is 3 and B is 2, right? It's just a relationship between them. So whenever you see ratios like that, keep that in mind that you can set up theoretical equations like the one I did here, right? All right, so now let's try the next one. This is the hardest one of the 3 for today, and it's the one that seems to be asking for surface area, right? Surface area of a sphere is SA equals 4 pi r squared. But you shouldn't really need to know that. And if you had a surface area question where you did need to know that, they would put that formula in the question. Here, they don't give you that. So we have to find another way to do it, right? And the way I would do it is think about how, okay, well, let's first read the question, right? A perfectly spherical orange is split into 2 equal halves. What is the difference between the surface area of the 2 halves and the original orange? The volume of the orange was 36 pi in square inches. Okay. So we're trying to find the difference between the surface area of the split halves versus the surface area of the whole orange when it was just 1. So you have to try to visualize it, right? You have I'm gonna butcher an orange, but that's okay. It'll just give me an idea. We have this orange, half orange, and we have this half orange that came from, this orange. And their outsides, right? If you put them back together, they would look like this. And the part that's new, though, is this circle here and this circle here. And we know the area of a circle, right, is pi r squared. So we have pi r squared, and we have two of them, so 2, right? So this leads us to this formula. So all we need to do is find the radius, which we can do based off volume. So we'll do that here. V equals 4/3 pi r cubed. 36 equals 4/3 pi r cubed. Multiply by 3/4. Multiply by 3/4. Oh, 36 pi, sorry. And then divide by pi, leads you to 27 equals r cubed. And like the last question, right? Cube root of 27 is r equals 3. And then we plug that in. So we're going to do 2 pi 3 squared is not 3 squared. And that gets us 9 times 2 is 18 pi. I know the writing is all over the place, but that just shows that you can write all over the place and still get the answer right. And I hope you follow that along. So this question looked like it was being about surface area of a sphere. And you might be like, I don't know that formula. But actually, it's only about the surface area of the circles cut in the middle. All right, and then we'll do this last one for today. This is a more typical SAT question than the last one, but still more difficult than the first one. So a chocolate sphere has a dark chocolate core with a 3-inch radius inside of a 1-inch milk chocolate shell. What is the volume of its milk chocolate shell in cubic inches? Okay, so let's just draw this out again, right? We have this core, and then we have an outside. And then from the center out, right, this is going to be 3, and this is going to be 1. The ratios there aren't great, but we have an idea. So this outside is going to be big sphere minus little sphere. It's going to be 4/3 pi, let's call it big R cubed, minus 4/3 pi little r cubed. Okay, so now we'll plug in. So the big R equals 4, because it's 3 plus 1, and little r equals 3. So we have 4/3 pi 4 cubed minus 4/3 pi 3 cubed. 3 cubed, right, is 27, just like 27 cube rooted is 3. So this is going to be, and 4 cubed is 64. So we're going to have 4/3 pi times 64 minus 4/3 pi times 27. Okay. And then this will get us what we're looking for. And then 64 times 4. Let's do that over here. Let's practice some column multiplication just for fun. 4 times 4 is 16. Carry the 1. 6 times 4 is 24. Plus 1 is 25. 256. So we got 256 over 3 pi. And you want to look at the answer choices, right? To know how much work you need to do. They didn't multiply out the pi's, so I'm not going to multiply out the pi's. And then they didn't divide by 3, so I'm not going to divide by 3. So I'm going to leave it like this. And then the other part, 27 divided by 3 is 9, times 4 is 36 pi. So at this point I look, do I have an answer that matches this, right? It's not going to be 128 pi, or 128 over 3 pi. It's not going to be 256 over 3 pi, and it's not going to be 128 over 3 pi minus 18 pi. It is A. Okay? So here, remember, you want to look at the answer choices to help guide your thinking. and to keep you from doing more work than you need and making careless errors by doing that work. Okay, so you can, if you know how to do this question, you're in a really good place for spheres on the test. If you know how to do this question, you're in a really, really good place for spheres. And if you know how to do this question, you're in a good place, right? This is the easiest of the three. It really covers the basics. If you have more questions on any of these or have material you want to cover in the future, let me know. I'm happy to do that and make videos on it. And like always, if you enjoyed this video or found it helpful, please like and subscribe to the channel. Leave any comments and questions you might have, and I'll see you all in the future. Bye.